Well, good morning. Today we're going to talk a little bit about really where what we've been doing is kind of leading up to. And those are the ideas of what is a scientific law and what is a scientific theory. So I'm going to give a little bit of background, and then we're going to take some notes, very short amount of notes, and then you're going to apply them on your assignment for today. So here's what we've done so far. We've been working on making observations. We did this with the Candle Lab. We did it with the deformed frogs. And then we've drawn inferences about what could be causing some of these phenomena. From that, we were able to discuss what is an independent variable, what is a dependent variable, and what is a controlled variable. And it's important that we keep aware of all of these when we run an experiment. We're only going to change one independent variable at a time. We're going to measure the dependent variable to see if it depends upon the independent variable. And we're going to try to keep everything else the same in an experiment. Those are called controlled variables. Once we've done that, once we have and are aware of that, we can now apply the scientific method. In a scientific method, we're going to make observations. We're going to form a hypothesis based upon our observations, and the important thing about a hypothesis is that we can test it. If we can't test it, then it's not a hypothesis, it's just a guess. So a hypothesis will be phrased as an if-then statement. If I do this, then this will happen. And the good thing about a hypothesis is that it can be wrong. We're going to now test our hypothesis. We're going to analyze the results from our experiment, and we're going to draw conclusions based upon our results. And maybe we'll confirm our hypothesis and say that we were right. Maybe our test will show that we were wrong, but either way we're going to learn something from it. Now here's what we're going to build from this, is that once we've done that, we're able to start going a little bit further. So if you could take a couple notes from here on out, it's not going to be a ton, but I want to explore where we can go from here. Okay? If we continue to get experiments that continue to verify our hypothesis, then we can construct one of two things. One of these is a scientific law. And a lot of people misunderstand the words law and theory. So a scientific law is a statement that an observation always occurs if certain conditions are present. What do I mean by this? Okay. So one thing about a scientific law is that it will never get broken. I can violate the speed limit. I could go home tonight and I could drive 90 miles an hour. I could violate a law made by civilization. But a scientific law will never get broken. Okay, never ever. Okay. Laws, unlike theories, do not try to explain why things occur. They just explain that they occur. So some examples of scientific laws include the law of gravity. Okay, if I let something go, it's always going to fall to the earth. Okay, that fulfills condition number one. It's never going to get broken. There's never going to be a time when I release something and it starts shooting upward towards the sky. But the law of gravity doesn't explain why it happens. It just explains that it happens. The speed of light in a vacuum. That is the speed limit of the universe. Nothing can go faster. That's a scientific law. It's not going to get broken. Nothing can travel faster than the speed of light. Okay? Doesn't explain why it's what it is, but it's just what it is. Another couple, Archimedes' principle, Charles' law. These are all examples of laws. They just say that they occur. They don't explain why they occur. Now let's contrast that with a theory. Okay? With a scientific theory, a lot of people misuse the word theory. A lot of people say they use the word theory and guess interchangeably. That's not the way it is in science. In science, a theory is a much, much, much stronger statement. Nothing is called a theory in science unless there's considerable evidence to back it up. So a theory, unlike a law, is an explanation for why observations happen. And it's supported by all the evidence that's out there. Okay? If there's evidence that disproves it, we discard the theory. So theories are very, very strong statements. They are not guesses. And this is the most confusing part about how people understand science. They say, oh, that's just a theory. You never say just and theory in the same sentence when it comes to science. Okay? A scientific theory is not a guess. It's not a hypothesis. It's an explanation. So, for instance, the theory of plate tectonics explains why we have mountains, why we have earthquakes. It explains why our continents are moving. That is a theory. It's supported by evidence, and it explains why things happen. Another theory of evolution. It explains why organisms change over time. It is supported by a substantial body of evidence. There's nothing out there that would disprove that. Okay? The Big Bang Theory, we'll talk a little bit about this later. All the evidence that's out there supports it. Okay? So, we're going to build upon this for your notes for today when you do this. But we need to compare these two and contrast them. Both laws and theories are based upon tested hypotheses. We've tested them. We know that they work. Okay? Both are supported by a large body of data. These two things are in agreement. Both are accepted by a vast majority of scientists. So if I say something's a law or a theory, science is going to accept that. But here's where the kicker comes in. The nice thing about science is that laws and theories could be wrong and could be changed if new data suggests so. If you get all of a sudden new data that suggests otherwise, you're going to change your law or theory. And this has happened throughout history, okay? For a long time, people thought Earth was the center of the universe. And if you looked at the observations, if you stepped out your front door this morning, it'd be awfully difficult to convince you otherwise. It wasn't until new information became available that people were able to understand that our role in the universe was not as the center of it, okay? Because Copernicus showed that the Earth revolved around the sun instead of the other way around, okay? Another thing that changed over the course of science is that Einstein showed that time is not absolute. Time is relative. Time is different for you and me, and that's a very hard concept to grasp, but that changed the way we think about science. Wegener showed how continents moved, okay? All of these are examples of situations where science has changed when new evidence comes up. So the great thing about science is that knowledge is strengthened by questioning what is accepted. It's okay to question a law or theory. That's part of the game. That's part of the way science is played. But you need to test your thoughts, test your ideas, test your hypotheses, and you can either confirm or reject your hypothesis. So the goal of these notes today is to show that there's a difference between a scientific law and theory, but that both are exceptionally strong statements and both are supported by a large body of evidence. So use that as the last part of your assignment today. And good luck in your assignment. If you've got questions, please take the time to send me an email and I'll get back to you.